Notes 8, Notes 8, page 4. I don't know if you've noticed, but the radical expressions we've been working with have all been one term. They're not always going to be that way. So what do we do if we have more than one term? Well, when you have more than one term, that means you're adding and subtracting. We will combine only like terms. And remember, when we're simplifying, we simplify within each term first. We want to see what each term really is, then we can see if they're actually alike. Also, we can distribute multiplication to several terms. These are all ideas that are going to come up. Quick review. Like terms have the same value. That's why we can combine them into the same pile. For example, 3 dimes plus 6 dimes is 9 dimes. They're all dimes, just put them in one pile. So if we have an algebraic expression like 3d plus 6d, well, d has the same value on both spots, so that's just 9d. But if you have 2 nickels plus 4 dimes, those are different values. It's not 6 monies unless you're about 2 years old or 3 years old. So we say 2n plus 4d. It's not 6 of any one thing. We can't simplify that. So that's a quick review, and these ideas are going to come into play. What if we had something like 2 square root of 6 plus 3 square root of 6? Well, square root of 6 has the same value in each place. And if you punch it in your calculator, it's about 2.449. So it's really the same as 2 dimes plus 3 dimes. It's really the same as 2x plus 3x, and x happens to be the square root of 6. This is going to be, I have 5 square roots of 6. So combining like radicals is going to be very similar to combining something like 2x plus 3x. When you see that the radicals are like, you wind up adding their coefficients. But over here, 5 square root of 2 plus 4 square root of 3, those are not like radicals. They're both constants, they don't have variables, but in terms of radicals, they're not alike, because the square root of 2, you can punch that in your calculator, that's about 1.4. But the square root of 3 is about 1.7. So this is very much like saying I have 5 dimes and 4 nickels. So it's not 7 of anything. So we can't combine that. Okay, so we cannot simplify. So we can see like radicals, unlike radicals, very similar to like terms, but also some subtle differences. So what we need to do is to be able to identify like radicals, okay, or know when they're unlike. So here's when 2 radical terms are identical or like. And there's a couple things you have to check. The radical part of the terms, they have to be identical. So the radical part is the part that's under the radical, inside here. So inside the radical has to be identical. The variable part of the coefficient that's sitting outside the radical, the variable part has to be the same, not the numerical part. So like here, the variable part outside the radical is nothing, so that's the same. The numerical part, that doesn't have to be the same, you can add those. So let's look at some pairs of terms, and we're going to decide if they're like or unlike, and if they are like, we're going to simplify them. So let's look at pair A. Take a second. Are those terms like? They are. The radical part, both root 7x. Outside the radical, the variable part, those are identical. So the way you want to see this, I would say this type of term, the best way to see this is this is an x root 7 kind of guy, and that's some more x root 7 kind of guys. I have 5 of these guys here, plus 10 of these guys here. So that's 15 of these guys, and they are x root 7x kind of guys. Okay? That's the best way to think about that. Let's look at the next one. This pair, take a look. Are they like terms here? And that answers no. The variable part, they're both 3x, that's good. I didn't say that right. The radical part, it's kind of late at night. Radical part, they're both identical, that's great. But the variable part, outside the radical, they are not the same. This is an x squared y, that's an xy. We wouldn't combine those terms. So those are unlike, we can't simplify that. The next pair, are they like? Well, no. Root 5, root 3, they're not identical. Under the radical, those are unlike. Can't combine them. Okay, the next pair. Seven root 5 minus root 5, are they like? They are. There's no variable part outside the radical, and they're both root 5s, but be careful here. This is one of the most common mistakes. I mean, this little problem shows up often, but it's often missed because people are just sloppy, just in a hurry. You have 7 of these root 5s and you lost 1 of these root 5s. You have 6 of these root 5s. Do you know what the common mistake is? People look at that and they go 7 root 5 minus root 5. Oh, just take away the root 5s, that's just 7. No way, no way. Okay, next one. The radical part has to be identical. And I didn't really emphasize this, not just what's inside, but also the index. It has to be the same type of radical. So they both are 6s under the radical, but that's a cube root and that's a square root. So those are different values, so those are unlike. So you're never going to add cube roots to square roots or cube roots to fourth roots. It's always going to be the same index. Square roots to square roots might be like, cube roots to cube roots might be like, but never a mix of different types of roots. Then this one here, these are unlike, and we will be seeing expressions like this a lot. So don't even try to tell me that's 4 root 10. These are 2 terms. This has no radical, that is a radical. They're unlike. 2 unlike terms. You cannot simplify this. And we will get problems like that, and I will see people try to make that 4 root 10. Don't do it, okay? So that's a simple beginning, and then the next page, we're gonna use these ideas with, of course, harder problems.